live. So, nice, we're live. Good. Sasawa. So, but as I said, there's no formula with this. We just do it the way it comes. I want to call it winging it. It's not really winging it, but we're like having like a formula and just being almost like authentic in terms of how when we meet, we just chat like over maybe in the hallways, at lunchtime. Mm-hmm. Yeah. So for today, we just want to have a conversation. I hope everyone. I think I thought the volumes are good. I think from what I can see here. Testing. So guys, if you're there, if you're joining us, you're welcome for this live stream. I think you saw from the poster, we have a guest here, Kemunto. I call her KO. Kemunto Ochwang'i. She's a software engineer at Microsoft, but also I know her from the cybersecurity circles. She's really deep into cybersecurity stuff, reverse engineering. She also talked a little bit about that. But for today, also my co-host here, who I always just pull in last minute, and I just told him like, hey, we have a session today. He wasn't sure whether he was coming or he was supposed to join online, but you're here, so I'm grateful. Thanks, Clement. Also, I was to host you like officially, because the idea was that we host someone before they become a co-host. Then I think your session will be coming soon.
No worries.
Yeah. So good. So let's get started. So welcome. I just wanted maybe to start off with your journey to tech, like how it started, like from the beginning. Just start from the beginning, whatever it was, like your first interaction with computers, and then how you got interested in this.
Yeah. Okay. My story is a bit interesting because I kind of found myself in this field without wanting.
Okay.
Yeah. So when I was in high school, towards the end of my high school, I needed to find a way to like take myself to a good school. Yeah. And by that, I knew that I had to like be good at math. Kwa sababu kulikuwa na this math contest, right?
Yeah, math contest, I remember.
I don't know if you participated in.
I did.
Yeah, like the Mangu one.
But I never came to these sides. For me, I was in Western Kenya.
Okay.
But we just used to hear about the Mangu math contest. But first, there was another one in another school, I think. I can't remember. Yeah, but I did like a few of those.
Yeah, so the Mangu math contest was like the math contest. Yeah, and the prize was a scholarship. There was a scholarship prize to like free university, pretty much. Yeah. So towards the end of my Form 4, I had one contest that I was going to at Strathmore University. Long story short, I got a scholarship, full scholarship to Strathmore University. Yeah, and I had to choose between four courses. So there was there was actuarial science, financial math, I think, telecom, and computer science. Yeah, so for me, landing in computer science was pretty much multiple choice, like crossing out. I wanted to be a mechanical engineer. Anyway, fate brought me to computer science. So my first real interaction, like serious interaction with a computer, was in my class, C programming. I remember being very scared to like turn on the network, just setting up the desktop. I had to ask my neighbor to help me with that. So for me it was like really grassroots. But then from there I guess I gained traction, like understanding of how computers work pretty much. By the time I was in third year, I started getting into the community. So I was out there doing hackathons, stuff like that. Yeah, that's pretty much how I got into the field.
So like you started off your first you started with C. Your first language.
My first, let me say, language that I learned in school was C, but the one that I created my first system was Java. I had a group, this like pairs of groups, and there's always the person who does all the work. So I ended up being the person having to, set up that project. So
nice. Good to hear. So that's a good but in at Limur, you're at Limur, right?
Yeah.
So and there was no computer studies there then.
There was, but at that time I was more concentrating on getting the grades. So I went with business studies.
I see.
The easier the better, I guess.
I see, nice. Nice. Now that you're here, that's awesome. So on your and then tell me a little bit also about, before we just go to the main topic of today, a little bit about your interest in cybersec, how you got into cybersecurity,
So for me, if I can remember it down to the exact point that got me there, I have two. An official one was that when I was in high school, my brother used to download these videos, the how to hack Wi-Fi. And I would see him checking this out. So I got kinda, that was my first introduction to people can actually do this stuff. But my, let me say, official one was in my fourth year. I was working as a IT technician at iLab. So in 2017, I think, there was Africa Hackon was being hosted there. So at that time I had to be there to help set up the cables, internet, make sure people are okay. So I remember being interested. I'd be like, okay, let me try this competition and see, what's up. So I was very scared to get in and do it at that time. So what I did, I actually started in the evening. So in CTF competitions, there's usually that graph to show how people.
The graph. I've seen in Try Hack Me, the graph up there.
This person.
Those games score.
There's a point on when a person does a challenge. So for me, my graph was it started at 7 p.m.
The previous day. No. Next day. Everyone's graph is already
So it was a 2-day competition.
So
it started Gioni. So by the morning, I was the top actually.
What?
So coming in, people didn't know who Phantom was. So
what is Phantom, man?
What is Phantom?
Because normally you're interested to, when you're starting off, you just seeing the guys. The name, the familiar names, and then you really just see Phantom.
I may just put something no one to know me. So by the end of that competition, I was, I think, 5th place. And these guys, because of the whole women trying to, they stood me up on the conference. So anyway, that was my first interaction, I guess, with this whole.
What kind of competition is it?
Capture
the flag?
Capture the flag. Yeah.
Nice. And we also talk a little bit about you. There's a channel you run, that you invited me. This channel you do.
On the Telegram.
Telegram, Talk a little bit about it, and also maybe we'll link it in the description for those who are interested to go into this stuff.
Okay, so this was my attempt to share stuff, because it's harder to get people have consistency in okay, let's meet every week or something. So I have this channel where I post resources that I encountered throughout my learning. That's pretty much it. It's not a sophisticated group of so I make sure I tag things well so that they can be findable, but that's pretty much.
But I like the way you organize things. You even It's not that we became a bit unorganized ourselves, but you're trying to, even there's a time you wanted us to do weekly challenges, remember?
Yeah.
And even have a Discord server. So I think I would like just to encourage you that those things are really awesome and just keep doing them.
Yeah.
For me, I think and this is a trick for me that I use for anything that I run for community stuff. My trick is having my expectations very low. I just do like, even if I have 2 people,
it's fine.
That's okay. So basically, if you have like 2 people or 1 person, that's good to go.
Yeah.
So that just keep doing it. That's how you actually build more people. Because the more we are in this stuff, I think the better. Yeah. So good stuff.
Just a quick question. You said like I don't know if I had it correctly. You stood up on stage.
Oh, okay, not on stage. So the whole story is a bit cheesy. Maybe I talk about it a bit. So I did this competition, like no one knowing my name. So I used Phantom, right?
Yeah.
At that time I was
working. Like
it was not even my happiness.
No, but they just like came up with that like quickly.
Phantom is Levanto.
I see.
Yeah. So, and at that time I was pretty much into cables, walking around. Yeah. So, one person that works in iLab, he's called John Ombagi, Trun. He goes by Trun. He's actually the person who started encouraging me into stuff for reverse engineering. He used to give me the resources. He gave me my first book resource.
Oh, that's true. Okay, I've seen Trun from there. I've seen Trun somewhere. Okay.
Yeah. Anyway, so he knew that I was the one who did this, who was Phantom. So he told the organizers, right? So me, I'm like, okay, I got into the conference, when they're about to announce people. So it's like, let me get out a bit, get some samosa, come back. So I come back, he sees me sitting down, talks to some person, and he's like, okay guys, we have this. So they show the graph, they're like, this person started at this time, and it's like, Phantom, stand up. Yeah, so that's pretty much what happened. I stood up.
I see.
Yeah.
Good stuff. But how's actually, maybe we should dig a little bit deeper in that, because I know that in the hacking or whatever cybersecurity community is where we have people talk about chauvinism in tech, in dev, but I think in cybersec it's a bit even more. And because but I want to know your experience that has been like in that group, but also one thing that I've really loved, I think the SheHacks group, like SheHacks it's called SheHacks Kenya. SheHacks Kenya has really changed the narrative. Like actually most top now cybersec guys are actually ladies. That I know, and even when I was trying to do, for me, I try, I'm not really into this a lot, maybe in future I would like to go into it, but I was trying to do this hack me, and one of in the advent of, it's called advent of cyber, they do it in December, one of the featured articles were from SheHacks Kenya.
Yeah.
So I was really impressed, this is awesome. So how has been your journey, being a lady and in this community? How have you pushed your way through it?
One thing I like about cybersecurity, the whole space, the hacking space, is that you can exist with a pseudonym. Like you don't have to be known that you're a lady, you're a dude. Because of that, I've never had a very strong stand on getting women into the space. For me, it's always been, it's a field that is very meritocratic,
Yes, that's
if
true.
you're good, no one will really care if you're a lady or not. At least that's my experience.
No, that's true. And even in that CTF that you talked about, nothing, it was nothing. It was all about merit.
Yeah. But I understand the whole, the space is very dominated with, especially if I talk about the local space. It's very dominated with men as opposed to women, even though I don't find that being I don't know, it might be a bit, but I don't find it to be a bad thing, because if you're a lady who is interested in this, then you will definitely there'll definitely be communities that are there to support you, regardless of like, you know, it's not always like, okay, you have to go to a female-centric community to grow. Africa Hakon, for example, is very, you know, anyone can be there. There's HTB, Cyberdelia, you know. It's all about your passion and like you wanting to actually get help, or like get guidance or be in the community. You definitely grow despite your gender.
Yeah.
I guess.
Yeah, awesome. But I like it that we are getting. I think now we are going to post those the era of the era of trying to say, oh, women this or men this, because I think we are getting to. I think for me, I feel like we're getting to that place of parity where, like for example, when I think about the top devs I know, it's a mixture of men and women. Like it's not really just like one gender or something. So I think we are progressing towards post that era. So. I
think the big question, or like the big point of concern should be people in, you know, underprivileged places, you know, like it should be, for me I think it should be more like either geographical or like community based as opposed to gender based, you know, because when you say, okay, let me go back to my village in Mombasa and create a community of women or like ladies and bring them up, I am effectively secluding the boys, you know, from the same community who could have a chance to learn and grow. So for me, I think it should be more like if it's, I want to make a change in like the community in Mombasa where I'm from, let the geography, I don't know the right name for it, or like let the space be inclusive of both female and male. Yeah,
that makes sense. I like that. Awesome. So let's go to the main topic of the day. Today we want to talk about, I think maybe for those who didn't understand myself also I didn't understand that topic. Just kidding, but we want to talk about generally around, I think it started off with just a conversation we had with you, like these days there's that people, the lack of interest in the fundamentals, like people just want to do the easy thing because it's easy to pick a framework, build something on top, and actually you actually do greater things with just building on top of things, but in terms of those who really care about the craft, you really want to know exactly how were those things built. And even, I don't know if it was you or someone else who were talking about an analogy of, you know, this company IKEA, those who came up with this idea of they do mass production of furniture and then you can self-assemble. You know, now at the end of the day, now devs have become just the people who assemble the things, but not the guys who build those the furnitures. And then again, at the end of the day, the furnitures now look the same. There's no craftsmanship where you feel like this software, as much as it's the same, it feels a little bit different. It works a bit different. This is faster. This is blah. But that's okay. That's another idea. But the main thing was around the fundamentals. How are those chairs built? What makes like a good chair? And just from ground up. So we are losing that knack for wanting to know the lower level. Because either way, one thing, so I'm just giving my own monotony here, dialogue, whatever, my own preamble, that one thing that I've noticed is that without knowing the fundamentals, you can still be very good. And even you can even rise to whichever level that you want, right? As a dev, you can be that senior, right? But there's a particular point where there's what I might call a breaking point. That now, without the fundamentals, you start seeing. And that's even where the real, the real imposter syndrome will kick in. Like where you go to a room and people are talking about things and they expect that at this level, because we're all seniors, when you talk about this, everyone should be knowing. I don't need to explain, and you're feeling like, wait, everything's just flying around because you just lost your you feel like now I feel like I'm a real fraud. But the truth is not that really you yourself you are a fraud, but rather you just overlook the fundamental stuff. So now over to you.
For me, it's been more like I guess a mantra, or like a way to curb my curiosity, like just fly. I feel very uneasy when I'm having a problem or I'm having a situation, and I don't really understand how it works. Like down to the bare bones. I don't know if and breaking systems makes this this requirement more real than building systems. As you said, you can be a successful engineer just building on top of frameworks, right? Or building on top of this. But for you to break a system, you need to really understand how it's built, like how exactly it works. And that's pretty much why I veer towards that side. It forces you to like be the engineer who wrote the stuff, or be the
Talk a bit more about breaking, like at least for me and you, we understand breaking systems, but people might be wondering that. No, I want this channel to be for everyone, even someone just leaving high school. And they want to like break a system. What is this thing being broken? So explain a little bit more about breaking system and reverse engineering, like the stuff that you like doing. Just trying to unpair.
Okay. My main entry point is CTFs. So
capture the flags for those who TTF.
Capture the flag competitions where you have a bunch of topics like insecurity that you can follow through. So my interest is cryptography and reverse engineering. So if I start with cryptography, for example, for example, RSA, right? RSA is this what's the word? Asymmetric encryption, right? Where there is use of a public and a private key, right? Now, for example, the depth of that's like the high level, right? The depth of it is like how exactly does RSA achieve its security, right? For example, it's like it's based on what is this called? It's based on this concept that it's easy to multiply, but it's hard to factor, right? So that's like integer factorization is where RSA achieves its security, right? Another simple encryption algorithm technique is the simple Caesar salad. Sorry. Caesar encryption. Sorry. Yeah, Caesar cipher. Thinking about food. Caesar cipher, right? Where you have this alphabet A to Z, right?
Yeah.
And then you have this variable, let me call it a number variable, which defines how you shift this alphabet, right? So instead of A to Z, it's like C to... Yeah, when you shift the other side, C to B or whatever. Yeah. So now that's like the high level, right? But you'll ask, okay, how does it work? And it works by modular arithmetic, right? Because like, okay, I don't want to go to blabber, but it works by modular arithmetic. So that's like the when you remove the abstraction of things, you actually get to like zeros and ones. What I mean is like things become simple when you go down, yeah, because you strip away the complexity and you're just left with facts. So for the cryptography stuff, actually I did a presentation once by SheHacks. Maybe I can give you the link to the to the presentation, where I presented approach with that approach. For reverse engineering, reverse engineering, maybe let me give an example flow. You're given a binary. That's already compiled, that has libraries linked to it. it might be stripped. By stripped meaning the debug information is removed. So pretty much when you're looking at this binary, you can't really tell the function names or like the actual memory address. So this is something called position independent executable, where so you're given this binary that you pretty much don't know much about how it was when it was being built, right? So you need to work your way up to understand what exactly does this binary do, right? So in that way you're forced to like, all right, your first thing that you'll be looking at is either hex code or assembly, right? In that case, you need to understand how exactly does a function get loaded to the stack, right? You need to understand, does the first parameter get pushed into the stack first? Is it the order of this? You need to understand exactly how the heap works, so that after that, okay, I understand now. I see variables get pushed into the stack, and then the return function, and that's the wrong order. You push the return address, and then you push the variables, and then you call the function, right?
Yeah.
So this, you're looking at it in the hex/assembly type of view, right? And then when you look at that, you need to understand that, okay, so how does this data get transformed? Or like what happens inside for you to build and then come with a pseudocode and be like, okay, this piece of this block does this and this, and then after that you can be able to find vulnerabilities or exploit. Yeah. So in a way it forces you to like think all the way down, to like the
I think I never. Go ahead. Sorry.
Just out of curiosity, like when you are, let's say, you're trying to understand how something works, at which level, like the bottom, at which level as you're digging down, do you feel like, okay, I'm confident enough, I've learned enough, like maybe I could go like, tackles all the way down the bottom of the rabbit hole, but this is good enough for now. Like, where do you draw the line and say, okay, now I can move on to other things?
For people who know me, they know I tend to go through rabbit holes all the way. Let me give you an example. So I talked about cryptography, right? So that presentation was actually my culmination of 6 months of trying to understand like the depth of this algorithms. I went all the way down to like buying a book about Galois theory, group theory, to to like understand the basics of how this stuff works. I'd say there's definitely a need to like know the limits. Even though for me, my personal thought is that there shouldn't really be a limit. Because I mean, okay, there will definitely be a base point, right? It's like you go all the way down to computer architecture and you reach the
resistors and transistors.
Yeah, exactly. You reach some P, I don't know what they're called. All the way down. Yeah, exactly. Actually, below the logic gates are built on some N and P value capacitors.
Right. Yeah, those capacitors. Up and downs and stuff.
Yeah, you'll get there and be like, okay, now if I look at the computer, I'm like, okay, now I understand. When I write this piece of code all the way down.
Because then,
yeah, I think to get all the way down is like based on curiosity, but it definitely helps.
Helps,
especially it helps.
And I think also it creates that every time you always see something, that there is something it's built on top. Like basically your idea, whenever you see something, you don't take it at anything at face value. Like you always want to unravel like what's beneath this.
Yeah.
What is this thing? I don't know. There's this analogy of something I'm trying to remember. But if you're used to breaking systems, no, like a good example is my son. So my son, he has this thing like when everything everything that is new that he had, he'll drop it down like just to I don't know why. So whenever he sees that, like I was like, okay, this look like a hacker. Like he'll be a good hacker because to know what this thing is made of, you want to break it. and just see like, so you like anything you at some point, this days he's not doing that anymore, but at some point he used to the first thing he does is to drop it down to just see like, if he is unable to open, just keep dropping it down so that it can open. So I think if you have like basically that becomes sort of your way of testing systems and checking things. I think it becomes sort of like your framework of solving problems, and you'll apply it to any other thing. I guess.
And there's this okay, let me call it a misconception. There's this like misconception that breaking systems is messy than building them. Because when you're breaking, you're just ramming through. Okay, in the analogy of like CTFs, you're just ramming through until you get the flag. As long as you get the flag, you don't care how you get inside. But in truth, or like even in the practical, like real world type of things, you have to be very meticulous. You're pretty much like, you need to understand, first you understand how the thing is built and how to extract what you want in a very elegant way that you leave things as you found them. Pretty much like a thief or
not just like everywhere you go, you're changing, you break a door, you don't know how it was even.
The
you don't have to return it. Like, sorry, I think I get your point. Like, if you need the analogy of a robber, like those who are meticulous, they'll break into, they'll open the lock and do everything and then return it the way it was. But those who don't know, they'll just maybe use brute force, they hit, then they take. So you're talking about the former.
Because the problem with the latter is like, okay, I'll break the door. Someone comes, the door is broken. You're fine. They'll know something happened here, right? Or like you open an aerial, the analog type receptors. You open it and you can't really put it back. Then it removes first the point of doing the first thing, because if you cannot be able to put it back, it's like you didn't really understand how it was built.
I see. Wow, that's awesome. So, just a recap of I think I was just recapping on what you mentioned. I never thought about like understanding systems. Maybe breaking them is one of the best ways. And actually, it's now making more sense to me. Like the more I think about it, the more it makes sense in terms of breaking. Normally, you will do from top down. I think so, right? Like if this is the house, and the only entry point is the top, or if it's a system and the only entry point is the API. Start breaking from the API going backwards. You don't have access to the servers, the backend servers, and even the other maybe federated server. So you need sort of like start from the entry point. So it's more of a top-down sort of approach. Most of the times when I was learning about like things, I prefer to go bottom up, but I think top down makes more sense to me right now, because it means like you understand if it's the API you're building, you understand of course how .NET was built or how the framework you're using was built, then going to like the .NET itself, CLR, whatever, all those things as you go in, or is it am I getting it wrong?
No, I think it depends.
Or either way, okay.
Okay.
Go ahead.
Because bottom up. It's like how.
And this is not about elections.
I think it depends. Like this type of approach, there's no like one specific way on how to approach it, right? I think it depends with how you're comfortable, or like, because there's the other thing, like, okay, I don't really know what a paper is. Okay, now I guess it just depends.
Yeah, depends on
the point here is that if you're starting from bottom up, it should be where you're starting from. Then you need to start from the beginning, right? Down there. If you're starting from top down, you start here, but make sure you go.
You go up the way. Don't get top less than you leave it. Okay, I see. Makes sense.
Yeah, but the way Clement said, it's like I figure that when I'm talking, it seems a bit idealistic, right? Because you can go all the way down. Like, how do you know where to stop? That I can say, I guess, if you have time, curiosity.
It's all the time, and do you think it's important to sort of like in an organized way? It's important to do like maybe even a curriculum of your own personal curriculum of the things that you need to know all along that road, and then there are things that maybe you might just say, okay, for this one I'll come back to it later, like. But you know it's there. Like it's more of when you're walking through a forest and you know the route, you know, okay, I've seen a good scenery there. You say, okay, no, I'll come back to this. Let me go up to the end first, or let me go up to a particular point, then I'll come back here. So I think it's okay to keep going. If like you don't have to really like do everything step by step, right?
Yeah, but there is always a main branch, you know. There's
always there's always the main road, and those feeder roads there. Yeah.
There's this book I read. I can't remember the name. If I remember.
And actually, what I'll do, like, you send me all the like your book recommendations of some of the like around this topic that you've talked about.
Sure.
And then I'll just put it in the notes. Yeah.
But what I loved about it was like after the preface, you know, before the chapters, it has a sort of map that shows you, like, start here, start chapter 1, and then it's like, okay, go this way. It jumps, you know. It's like, okay, when you're chapter 2, it says, okay, maybe go to chapter 4 and then come
back.
I've seen
the book too.
I can't remember the book, but I loved the way that approach was like. You know, it's like, okay, you have this big Bible, right? Like, okay, C programming, you have this big Bible. It's like reference book. But there's some things that you need to go, there's a part that you need to follow. Right? Because you can't proceed to, let's say, chapter 4 before chapter 3. You'll end up, in that case, you'll end up brute forcing your way as you go, right? Yeah.
Yeah, I think I've seen such a book too. But I wish I had a book here. So the CLRS book, the algorithms book, I think also has such a thing where they say, okay, or in the preface, okay, I think it must be the CLRS book because it was written by the 4 professors, and one of the professors, I just came to learn, one of them was the one who came up with that RSA, one of the R's. You see CLRS, the R there is the R in the RSA. Ron is reversed.
Okay. Nice.
So reverse is one like also. So actually, like all this stuff I've never known. I knew the RSA algorithm. I knew the CLRS book. CLRS book, I think I'll also link it here, guys. CLRS book is like our Bible in computer science. This book, you know, I found a way of projecting this thing also as so they can see it. Yeah, so that's the CLRS book. So one of the R's in that book is called, I think, this one. Let me go to the authors. So this is a professor called Ronald L. Rivest.
Yeah.
So this prof is the same guy who did RSA. Is the R in the RSA. Yeah, so really, like when I just saw that, I said, oh no, I have to buy this book now for real. So that's why I went ahead and bought it, and it's just really awesome, and I always feel like I need to go back and read those books like just properly, yeah. Because sometimes someone can ask why, what for, like I think. Those was for what for, maybe by the time you ask that question, maybe it's not for you. But those really know, like just who love knowledge and love to understand the things, concepts, I think they will just get it. Like why you want just to read something for the sake of reading it, not because you lose it tomorrow in that code that actually you have a bug that is bugging you. So like you only use it tomorrow, but you know, but somehow again. In life, it will just come, like you use it somewhere. You never know, you just use it somewhere.
I have two questions. The first one is when you talk about like whether you go top down, bottom down, or following a map, it seems like traversing a graph. Maybe we call it a knowledge graph. And you said there's a main branch. And that got me thinking. It's like what I've noticed is like everything is kind of like a rabbit hole. And at like if it's a graph, it's like every node, it's like the node itself is a subgraph which you can zoom into. It's like fractals.
Yeah.
Yes.
So it's it's like you can decide at any given point, let me focus on this, and that can be like a topic that you end up spending years if you wanted to specialize in that topic. So it's like, I feel like you can have a choice between having a bird's eye view of everything,
Yes.
or you can pick specific points in the node, in the graph, and say, okay, am I specialized in this and this, and I'll just have like a cursory view of everything else. But it might feel like it might be impractical to explore everything.
Yeah.
To its full depth, and still be and still
It's
be-
almost like in a forest, but you go and visit every tree, right? But there's a way you can traverse the forest and actually get a good view of the forest without really having to go to every tree, right?
Yeah, it's like it becomes an information overload pretty much.
That's
I think it gets to a point where too much knowledge, too much unstructured knowledge is not helpful. You know, it's right?
Yeah. So maybe I don't know.
It's like if you try to learn everything, you know, everything.
Yeah.
Yeah. So in that context, then the question is like, what advice would you give maybe to someone? You know, like let's say someone is watching this and like they feel inspired by, you know, the kind of depth that you have demonstrated, your approach, and then maybe they feel like, okay, I want to be like that, or maybe they even feel like a fraud, and they feel like maybe I need to learn this or read this to not feel like a fraud. So how would you advise someone like that to do it, maybe in a way that is practical, so that they don't like get lost in always reading the next book, or like maybe they read a chapter and then they find it requires this, and then it mentions something they don't know about, and then now they pick another book to read to try and understand that, and at the end of the day maybe, I don't know, like what's the practical way?
My approach, or the way I do things that is not too much rabbit holes, is, I would say, first, try to go a level deeper. Where n is more than 1, try to go like 2 levels deeper. And what that means is like, don't look at things at the face value and be like, that's fine. But like, okay, you have an algorithm, right? Don't just say, okay, I understand this is public-private key and this is how it works. You need to go a level deeper and understand. For example, the level deep than that would be like, okay, how do they create the public key from the private key, right? You understand the math behind that, and be like, okay, then how exactly is this thing secure? You go down to like, all right, they use integer factorization and stuff. For me, I think n is equals 2 levels deeper would be best. It's like, okay, you're a boat in the ocean, right? You need to understand the boat itself, and then at least have a view of the ocean. Like, how does this boat traverse through the ocean? Like, move through the ocean. I figure that's too high level. I'm trying to be as general as...
I watched one presentation once where I think the speakers were actually discussing a similar topic, and one of them gave two approaches like that you can follow. Like one, he said like depending on what you're working on, or maybe what you're working on, at least understand 1 or 2 layers of abstraction below where you're working. If you want to go deeper, that's fine, but at the minimum, at least 1 or 2 levels below the one you're working on. Don't just know what you like. If you're working, let's say in front end and maybe React, at least at the minimum know basic JavaScript. Or maybe the browser, or how the browser works, or whatever. Don't just settle for what you'll be working with day to day. And then the other approach is like, when should you learn these layers of abstraction? You had two suggestions. One, if you are like a curious individual, like if it's something that really excites you, then just go for it. Like don't wait for when. Just if you have the time, just go for it. But if you are like a results-oriented individual, you can just do it when you need it. Like if you survive this far without knowing it, then you're good. If you feel like to solve a particular problem, you need to know this thing, then that's when you dig it. So it's like depending on how much, like, if are you really interested by this stuff for the sake of the curiosity, or you just want to solve a particular problem, and that's when you need.
Okay, but I think also it could be a fact of like, do you want to take time in the beginning, or do you want to take time as you go on, right? I feel there's some things that if you understand in the beginning, it's like it saves you time as you go on. It's the same thing as like when you're trying to understand a new code base, for example, right? There are two approaches people take. Some people just go look at the examples that are given, like, okay, this is what I need to do, alright. I install, I try .compute, or you just follow the example that is given and come up with your result, right? But that gives you a very narrow view. But like, okay, I don't really understand how this stuff goes, right? But if you take time in the beginning, like, okay, let me look at the documentation a bit, browse through the code base, understand the flow, or understand how stuff works. Then when you now go to like implementing or whatever, using the library, you're saving yourself some time in like understanding, because if you go into it without really digging through a bit, you find yourself dependent on like always going to Stack Overflow, right?
And that's actually true. I feel like this is just a personal opinion that in the dev community we joke a lot that everyone is just Googling and Stack Overflowing, but in practice I don't find that to be true. Like in practice I find that when you rely heavily on Google and Stack Overflow, you actually struggle a lot in programming, and like most people, like they write a bunch of code, and then one thing they forget, then they go look that up. It's not like they just looking up stuff and then they pull stuff together from different sources and then they throw it in the copy paste and hope it works.
I actually found out that it robs you of the time to think. What I mean is, if you rely heavily on Stack Overflow, Google, you find a problem and you go to Google, how does this, or like, how do I do this? But if I started from a point of like, okay, I understand how this library is like, or whatever, I at least know like how it functions, or the method that are specific to me to call, right? Then in a way, it becomes not like, all right, I have to Google and understand how do I call this, or how do I do this. You start, like, it gives you time to think out a solution before. I don't know if I'm making sense, but
yeah, I think for me it's making sense. Like what I'm writing here, Stack Overflow driven development versus versus you just thinking about first understanding the tools you're using, the problem, and then some of them come in where it's more of reference. It's not like actually solving. It's like, I've forgotten this. What was this? I've forgotten this method. Like, I remember there's a better method than this. Not there's a better method. Then you Google.
Yeah. Actually, you're right. It's like more like reference as opposed to like, okay, how do I?
How do I reverse a string? Like, you already know the concept of reversing the string, but you've forgotten how to swap, for example. But then how will you swap? Okay. But I love that approach. I was really busy trying to fix this. I missed the conversation around the that you guys gave a tip that maybe one or two abstractions down is good enough, right, to start, right? So I think I've just noted that down. So I think that's I never thought about it that way, but because normally for me also I didn't know like where do you stop. just not like at some point I should learn most of these things, but I think as a general, like maybe practice for everyone is like the median should be 1 or 2 abstractions. They just want to go deep up to the 10th, 16th abstraction, can do that.
Yeah, I have another question / comment. This is in reference to something you said at the beginning about like nowadays it's very common to find maybe people who don't understand like the building blocks or the fundamentals, and they still able to actually get work done. So maybe using frameworks or higher level libraries or abstractions. So I was just wondering whether is that a bad thing or a good thing? Because I'm kind of I think it's like a double-edged sword.
Yeah.
Because one way is like the industry has grown. The number of problems that they have to solve has also grown. So I think it also helps that it becomes more accessible to more people, so that at least there are more people involved in solving different kinds of problems.
Yeah.
And then also there are different like levels, or not levels, but it's kind of like choose your own adventure. Like you decide what your career you want to be, what you want your career to be, or how you want it to evolve. Because not everyone wants to be doing assembly or wants to care about assembly, but there's still space for them to be productive and actually highly effective in a team. And then also, not everyone wants to, like, there's something for everyone, and everyone can find the fulfillment they want, and they can go up to as high as they want, or stay where they want, or switch to different careers or different roles as they grow. So I think so long as there's enough of everyone, every type of individual, for every problem that needs to be solved, I think it's not such a bad thing.
Yeah, I think it's like what you said in the middle about fractals, right? It's pretty much a fractal. In each node there is like another subgraph that you can traverse, right? And just based on that, it's like I think at any level of like work that you're doing or whatever you're doing, there is always more that you can learn within that, right? Yeah, I think that's pretty much. It's you don't have to go all the way down to like the root node. No. It's like at that point that you're in, like maybe you're learning game development or C++, right? There is always more that you can learn within that. Right?
Yeah, maybe for me also, as I completely agree in terms of it's true. It's okay. Actually, most people should settle at that point. Like in terms of, way back for me, I used to be radical. Like I was more like everyone should go hard or go home. It was more like that. It was like if you're not for the like fundamentals and stuff like that, you shouldn't be in this field. But then I just noticed, like practically, like pragmatically, like the way you are saying, it's just okay to like, for example, use the framework. They don't care about how it was built. Once in a while you get a bug of that framework, you Stack Overflow. You find someone else solved it, then you just take the copy paste the fix. Oh, it was here. It's okay. And you actually do most of your work. 90% or less even 100% of most of like tech companies, you do it well, right? You just do, even you get promos and you'll be a good engineer. But I think the only thing I can say is that people should not settle, like that should not be the standard, where now the kids coming behind us, they should not just think that all I just need to do actually that's what makes people say, why do I need to go to the university? I already doing Python, I'm already building up. Actually I know a lot of Python than the guys who are, I met another 4th year who actually has no idea about Python, so they feel like their university is trash. They now, because university teaches you the fundamentals, as much as they, of course, forgiving how they teach it, but at least they sort of, for me, I feel like they give, for me, I always tell guys that the university should just be aware of you going to know the table of contents. Like, you just know, like, okay, you know, this, that, there's something like factors, there's something like this, there's whatever, and then you can go in and use them, Google, Stack Overflow, whatever things to do, to go and learn those things. For like as a way of, I know I'm deviating, but either way, so the thing is, guys coming behind us should not think like, I just need to know those, like, once I'm okay with the framework, I'm now a software engineer. And maybe we should actually say that actually, if you're just building those things, you are just, let's say the truth is like you are a developer, right? So if, I'm thinking about like in a construction, there is a civil engineer, like in any building, there's a civil engineer, there's an electrical engineer who does the electricals. And then there are those guys who come and connect the wires, the real guys who come and build. So people should not confuse those two people. Like if you're just into knowing the just laying the bricks and doing that thing, like putting the bricks and all that, you're a developer and that's okay. You'll be paid for the but if you really want to be a software engineer, I think you need to have to understand the abstractions, the concepts. So if someone comes to you and say, oh, Made, we have want to change this, like the direction of this thing, you don't now start wondering like, oh, how do I do it? Because you already know the concepts, you can be able to go and just know like, okay, I need to change this beam here, I need to move this thing here, and then it will work. So there's a place for developers, there's a place for software engineers, and it's okay. And because all of us actually cannot be that, because the thing is, if all people were civil engineers, there's no, actually a civil engineer cannot build a building. You know that most of the civil engineers, they've never held that thing that they used to put the plaster. They even don't know, some of them even don't know how the bricks are made. You see?
Yeah.
But they know the civil stuff. They know how to balance, load balancing and all that. So for me, I think everyone has a place. But now, if you're in the field of engineering, if you want to say like you're a craftsmanship or you're a software engineer, I think it's good to go into the fundamentals. What do you think?
Yeah. But I think it shouldn't just be, like it doesn't just apply to engineering. I think it goes...
Okay, not
right?
just...
So what do you feel about the like the low code thing, like the power apps? Because it's like, I think it's targeted, let's say, at maybe business people who are not. So would you now advise such a person, okay, you need to learn the basics of programming?
Like a business... Okay, there's like...
No, I think you got it wrong. I think we already said that. Like, there's a place for that. Like, that one actually, the business person should just know that local, like, if it's power automate, just know the power automate. Just know it to the best, your best. Don't worry about, like, it's running on top of M365 or something.
To the business person, the website or the thing that he needs is just a tool for him to do whatever he does on a daily, right? So in that case, he doesn't really need to understand how the stuff works, right?
Yes.
Beyond the maybe WordPress or whatever. That's it. But that business person, if he's working in finance or whatever, he needs to okay, I'm not a finance person, but I guess for him,
the
message is the same. The message is the same. Yeah.
But also, from the other side, again, I want to say, like, they should not be, and don't do the low code and then call yourself a software engineer now. So for me, it has to be very clear. Like, don't do the low code. So I want to just say that, basically, I'm trying to challenge the guys like who really want to do software engineering, that you need to understand the fundamentals. That's just my challenge. Or if not, it's okay. There's a place for not understanding fundamentals. It's okay, but don't. You're the people now who are making it now things like ICT business to become influence. Because now people are wondering, like, someone does the no code thing, and then they're software engineers, and then they can build maybe something. So let's say, for example, do you think people can trust a low code, no code kind of thing to build, let's say, a system for ICU, like that maintains ICU or people on high dependency units? You see, like, okay, I've used a wrong example, but let me say, will someone trust someone who does not know the fundamentals, let's say, of even, because actually if you're building, let's say, a hospital system or that thing to do like ICU, you also need not just understand your coding, but also you still also need to understand how does that pulse, because you need to get the pulse right, how is that pulse picked, how is that, like, the oxygen levels picked. If you just say, okay, I don't care, for me, I just use this sensor. Once the sensor brings me data, I really don't care.
I find that okay. It's an interesting question because I find that you can either trust the person who made the system, also trust the system through the person, or you can trust the system irrespective of the person, like by doing an audit or something like that. Or you can choose not to trust anything, because at the end of the day, like there's nothing guarantees that this system works. Like I don't even think it's like possible or like there's like algorithmic way of ensuring that a system actually does what it's supposed to do. I don't think there's like an algorithm for that. So it's kind of just like, oh, you have all these heuristics of, okay, maybe this person seems qualified based on experience, or maybe we have done an audit and we trust this auditing firm. But at the end of the day, I feel like it's just you have to pick what to trust and go with it. I don't know.
Yeah, that's true. That's true, but you shouldn't at least know. You shouldn't. When you trust, you shouldn't really leave the knowledge to them. Like knowing, actually maybe we should actually make it clear that knowing doesn't mean that you doing it.
Yeah.
Like knowing the abstraction doesn't mean that you're now going to build your own computer and then build your own OS and build everything. It will take you a lifetime, right, to build a good thing. But it's good to actually try those things to build for the sake of learning. But building so that you can use it actually in a production system. You have to trust now Microsoft to build for you the OS. You trust these other guys, but you should know how it works. I think we should not confuse trust and knowing, right?
Kemunto sounds.
What do you think?
This has a lot bottled up.
Mine is just everywhere.
What do you think about the trust and knowledge?
I think if my system is consuming input from another system, right? I would only be interested in knowing the quality of the thing that gives me the input, which is like, for example, in this case, the sensors. I'll be interested to know how the sensors get that information, and that I am getting reliable input into my system, and that's it. If I try to go, okay, how does the oxygen level, I am going down a rabbit hole, right? It's like you should be interested in like your input, and most importantly the machine that you're working. By machine I mean in a general level, right? The system that you're building on top of, or but like.
But how it works, because what happens is maybe someone comes to you and they say, but this system is. But there's a patient who died yesterday, and they were showing the right oxygen levels, everything was right. But because maybe how it works, and maybe even and you can ask them, okay, where was that thing placed? They tell you, oh, it was in a particular thing, maybe it was at 30 degrees Celsius, and just know those capacitors in that thing cannot work at that 30 degrees Celsius. If you see, if that's not at every software industry, but let's say if you've dedicated your life now to building systems for ICU, you should at least know those. See, now you're at one. I think that's two-level abstraction, right?
If I'm not the consumer, if I'm the one building the system that collects the data,
this for
right?
Me, sure.
But if I'm the one consuming the sensor information,
the guy building like the dashboard and all that. Oh yeah, okay. You should
right? It's like.
Oh yeah, I get it.
Yeah.
So I'm talking about the platform guy. The guy is building the actual interface, right? Should know. But the guy is just building the app that maybe an Android developer actually asking them to know about those capacitors. I think is too much.
Yeah.
Okay.
I think I'm lost.
No, you're saying, for example, it's good that you've said it because it means also some of our audiences are lost. But you're saying you are this engineer who is building systems for the hospital, and you're the known for building the ICU system that takes in, especially the vitals. Because in ICU, vitals are really important. Because in the moment oxygen levels drop to a particular level, a bell should be rung to get and basically it's an emergency, right? You have to stabilize the patient. So if those readings are actually wrong, right? If the readings are wrong, but the software is built right, the idea of the software is just to pick the readings and show, right? So You don't want to get in that situation where you just say, oh, my software is working okay. Like, let's test it. Like for me, I'm in this place, I'm not part of this problem. But I was saying that if this is your dedication, you should go a little bit one level abstraction to understand those sensors. Yes, they're getting you data, but how do they work?
Yeah. Okay, yeah, I think I did that. Yeah, I think the notion of abstractions are like, they are fundamental to software engineering and computer science, but they're also not pure. Like, I don't think there's the idea of abstraction is you can like build something in your domain, and then everything else, like, you can just maybe import and just assume that it works based on a certain contract or specification, and you just need to know the contract and don't have to care about the details. But then these things are not like, I don't feel like abstractions are mathematical concepts, so they're not pure, so they kind of leak here and there. Like sometimes the thing you build, like the leakages in the abstractions will affect your what you're building. So maybe it will misbehave or it will be slow, and then now you need to know the details of the abstractions in order for you to, like, maybe if abstractions were pure 100%, like everything works as advertised, there are no leakages. Maybe you could survive without knowing the details, but I think in practice, like they kind of affect how what you're doing.
That's interesting. Actually, that's very. But that's a very interesting point. Because most of the things that are perfect in the universe, we don't think about them. You don't think about how you breathe. You don't think about the air. But you want to check, like, is it air actually 16% or whatever? Oxygen, or, what is the composition of air? There was the thing that we learned. Is it like oxygen is some percentage, nitrogen, and so, like, you just, because they are perfect, you just go on with your life without ever thinking in the morning, like, but this air I'm breathing, how is it? But now but what you're saying is because of those imperfections in all the layers that we're building on top, they're not, we'll have trusted them immediately, like from the beginning, but because of the imperfections, it's just good to know exactly. So whenever there's a problem that will come, because most times it's all about, like, even the example I gave about a patient dying, it was all a problem. There's one bringing all those issues, like, okay, what really happened here? But if everything was running smoothly, no one will ever actually even worry about any of those abstractions. So it's an interesting thing.
It's like, if you have these frameworks that tend to be either cross-browser or cross-platform or cross-OS, and then they have like this nice interface that every OS implementation is supposed to follow, but then you have like some if statement that happens to know that there's this particular issue in this particular version of an OS, and so you need to account for that. And I don't know, it's just I find it amazing that those things are not as common, like maybe the fact that most of the time you can get away without knowing those details is like a testament to how powerful these things actually work. Because if you think like all the different details that have to be accounted for, that you don't have, that you take for granted, I think it actually, the abstractions work more impressively.
That's true.
If you're pushing towards the edge, is when you realize that the abstractions are a limit, right? And now you need to like understand how exactly the abstractions work or what they do, right?
Yeah, and I think it's just generally hard to design good abstractions. I don't think there is like a perfect formula. It's kind of like just intuition or best practices that and just hoping.
And then the problem usually is you build abstractions without really knowing the future part. Not to say, okay, I'm futuristic, I know, think about 10 years down the line it will be used, so how to build it for future proof. You build it maybe for that immediate need, and then in future now people are needing more other things. And because it's now 2 layers down, you can't go and change it. Now that's the legacy stuff. If you change anything, it breaks everyone who is using there. So you just leave it the way it is, and now you start having those piling of those pipe.
Turns into PHP.
So let's not use this kind of version languages. But then we have a function that is, you decide with a verb, then you finish this, then now it's a verb. That's PHP. So anyway, I don't know, another thing when you talk about abstraction, just felt like, also if you start knowing the abstractions, then you'll never be intimidated by anything. I think like someone can say, oh, this Linux. At the end of the day, just know. At the end of the day, this actually these things are just function. Even if I go to this, I know where the function for copy is. Like this one is just like actually it's about 10 lines of code. You see like something like that. Like so someone cannot like threaten you that but then I build Linux kernel. No man, that's just the first you're doing. But everyone just uses those heavy terms to maybe intimidate people. But if you go to down to the wire, they're just simple like constructs for a loop, maybe if else here, maybe there's a switch, there's this here. There's nothing magical. It's only that now because now it's in a maze, it's like if I bring a leaf here, a leaf of a tree, it's just simple, just a leaf, even you can draw it. But then if I bring a forest, it becomes now complicated. There's this river, there's another tree, and there's a vine, there's this different types of street. You become a bit like you say, I can never understand this forest. But at the end of the day, if you break it down into just a leaf or just a root, it just becomes so easy, and no one can actually boast like it's just about. Actually, it's more of anyone who boasts about anything. It's just anything magical they've built or majestic they've built. Actually, most of those things, majestic things that people build, they don't build like even by plan. They come by happenstance, like because you build a tree here and then you realize, oh, you need another tree here, then another one. Before it's a forest, and then you come boasting about the forest. But it wasn't really that you plant this forest. So, because you know abstractions, no one can really, or you can never feel even that thing of imposter syndrome, of someone feeling, do I fit here? No. I think.
I don't know. I will find that issue.
Mm-hmm.
I haven't found a good solution for not facing imposter syndrome.
Okay, but let's talk about imposter syndrome. But like I think this should always be a topic in most of our stuff, imposter syndrome. Because it's a thing actually. Even me, I can say like it's something that you fight every day, but let me hear about, at least you've talked about like how you do with it, but you can still repeat it today. But let's start with you, then we come to Kemunto.
Yeah, I don't know, I think as I said, I consider imposters, okay, I think there's a level of imposter syndrome that is maybe self-destructive. Maybe when you don't take everything into account, and maybe when it's too negative to the point that you can't operate. But I also see it as a practical self-regulation or regulatory mechanism, just to make sure you don't get complacent, and also to make sure like you don't overestimate your own abilities. I think in that sense it might help, because if maybe you achieve something, or you can get ahead of yourself and feel like now I figured it out, I kind of I have mastered this, and then maybe you are presented with a problem, or you work with someone who like what you just figured out is probably something that was bread and butter for them 10 years ago, and it's like there's so much ahead, and it's like okay, I feel like I've reached the peak. Who made this is just like food, and then there's like another So in that sense, I found that to be a good thing. But then I think the negative side of it is like if you're in a place where you're afraid to speak, you're afraid to ask questions because you don't want to look dumb, you don't want people to question like why you're here, and so that really limits your ability to contribute. I feel like in that sense it's a bad thing. So I don't use it like I think being aware of it helps, and then just I don't use that as the only thing that helped me know where I am in my career. So I also factor in maybe comments from colleagues, what my manager thinks, what my colleagues think, what people are working with. So that also helps balance things out, and then I take everything as input to know where to improve, what to work on, and also just it's okay to let's say I was actually an imposter. Because it may also be that I'm an imposter.
I actually had a question around that.
Yeah, cause
since you brought it up, boy. So, some people put imposter syndrome as like you think you don't know, but you actually know.
Yeah,
right?
Yeah.
But what if it's actually I don't know?
Yeah, so I could actually be an imposter. So, and in that case, that's what I'm saying. Like, what I really feel helps a lot is that feedback from others, not just what you feel. Like if your manager tells you something and your colleagues tell you something, and there's consistency maybe in what they're telling you, then it's most likely to be the case, whether it's positive or negative. And it's just like, okay, if I feel like I suck and these guys are actually maybe they don't want me to they don't tell me directly, but if I pass what they're saying, it does sound like I suck. And then I just need to work on what it is like to get to that level that I need to be. But yeah, it sucks to be an imposter. But I also say like it's okay to not be the smartest person in the room, or it's okay to be not that it's okay to be an imposter, but if you are an imposter, it is what it is. So now, like now is at least you know. So now what are you going to do about it?
The first step.
Yeah. So now, or if you ask, you just also say don't be afraid of appearing dumb. Like don't be afraid of asking dumb questions or asking questions that will expose you. If you're an imposter, like the worst thing you can do is persist in your imposterness. So I think asking questions, even if it's exposing your ignorance, that anything that can help you grow, I think is what will get you out of that imposterness. But now, keeping yourself in that shell, you just be more of an imposter.
Good point. As for me, I don't know. I honestly don't know if there is like one way of how to like get out of the imposter syndrome or like be okay, because like the more you know, the more you learn, right? The more you're looking at something. So now I open a book, I look at it, and I'm like, oh, I actually don't know this, right? The more you learn, the more you realize there's a lot more that you don't know. That's yeah. For me, I think it's not about like trying to remove the imposter syndrome. It's about just accepting that this thing is there. You know, it comes when I find something that I don't know, and.
But you can find something that you don't know. I mean, there's always something that someone doesn't know, which might be okay, but then you might be like, let's say, I didn't know this, and maybe other people knew it, but maybe there's some things I know that they may know, and I think that's okay. But it's like, do I really belong at the same table with these people? Like maybe the skill gap or the knowledge gap. Yes, there are things that I don't know, but maybe like even the productivity, the outcome of what we build. Like I just feel like these guys can take up this thing, such this task. Okay, they can be entrusted with this responsibility, and I don't even know where to start.
For me, I'd ask myself the question: am I even in the right table? It's like, okay, it's like going into like a meeting, for example, and you're completely clueless about the area of stuff that is about. Now the question is like, is it my first time in this meeting? If it is my first time in this meeting, I'll be like, that's okay. I listen, I ask questions, I learn, right? Okay, if it's like the 50th meeting and I'm still there and I'll be like, okay, there is something that I need to, you know, yeah. For me, my view is a bit cynical, very realistic, but I'll be like, the question will be like, am I really in the right table, right?
So if you have that question, what will you do about it? Like, what is the approach?
I assess myself, right? I'd assess myself. I'll be like, okay, why am I not able to do this task? One, have I been able to ask people about it? Yes, I have. Okay, did I understand? No. Did I go to the documentation? You know, like, did you try as much as you could to do the task, right? If it comes back and the answer is no, I'd be like, did I break down the task? You know, like, try to approach it as logically to like get the actual answer at the bottom. It's like, okay, yeah, I actually don't know C++, right? I can't be able to do this stuff in a week. Yeah, let me just give it to someone. Because there's also the thing about setting expectations with yourself and with others, right? Because it's like, you know, this you go to an interview or like job interviews, right? And you say, okay, I know C++. You say a lot of stuff. And you're like, okay, I get the task, I will learn, right? I will learn. And then you start the task and you realize, oh no, this will take a month. There's a lot of things I need to learn. Now the imposter syndrome that comes at that point is actually something that you need to listen to, right? It's not like, okay, imposter, push it out, try to do. Because realistically, to be like, okay, there's a lot of stuff I need to learn that will take me a month, and this work is needed in a week, right? To be realistic, I'd be like, okay, either I work with someone or I give off the task. I don't know.
Yeah, but you know, let's say you're in that situation practically, and you've been hired for a job and the expectation, and you realize maybe you can be, realistically, there's no way you can meet it. So, what's the right thing to do? Because maybe you might want to say like, okay, let me work with someone, or but you also fear that if you get exposed, maybe your career is in jeopardy.
Yeah.
Or do you like take that and just, okay, maybe I'm actually in the wrong job, maybe I should just be open about it and whatever the consequences come out, or do you try to like wing it and well, I don't know.
I think it's a fuzzy line, right? Because it's either that some people get to that point and like, I'm not cut out for it, but they do that earlier on, right? Before they tested themselves. And some people went all the way, you know, faking, and then realizing, okay, yeah, this stuff I can't do, right? I don't know. For me, I think it's really important to like have stepwise growth, career growth, right? It's like when you're just beginning, start at this is my personal opinion. Start at the point that gives you the chance to apprentice, to learn, right? Don't start let me give you an example. So you get into a company as a Python developer, right? I build Python backend systems, right? But you're given a task that is like, okay, you need to do some computer vision stuff, satellite imagery, right? There is Python involved, but it's a very specialized type of thing, right? Now, you can be like, okay, I will learn, right? But you realize that this is a very specialized thing that will take time, right? Now, it's important to like sit down and be like, is this task like a very blocking thing, you know, something that will expose me even more if I don't do it? If the answer is yes and I need more time, I'd be like, let me work with someone else, you know, or let me take a smaller task. Because the worst, for me, I think the worst thing is to like feed into your imposterness, either by giving yourself unrealistic pressure, you know, unrealistic pressure. It's good to be true to yourself, I think.
And how do you balance that with there's also like the common advice of getting out of your comfort zone, like do things that challenge you or that you're not even sure you're capable of doing as a way to grow and you know like challenge yourself to be better.
Good.
So place yourself in such situations, but where you can get challenged knowing that there's a risk of failure, but also not to the point where faking you, not to the realm of faking till you make it, like doing, like how do you know what level of challenge or unpreparedness is appropriate?
Okay, that's a head scratch. I read a short essay recently about importance of stupidity in scientific research. Actually, that's the title. And the person says that stupidity is a very core thing in research, right? Because for you to you pretty much need to find the problems to start looking at, right? And most of the times you're veering towards the unknown. I don't know. That's why I have a question to ask to begin the research question, right? It's good to apply that to work, to engineering, right? But there are a lot of other constraints that come in that you need to sit down and, like time estimates, right? Or like deliverables. It's good to push yourself if you know, okay, if it's something that I need to learn about protobuf maybe or something. Sure, you can be like, all right, let me go crazy for 1 week. I can push myself to that. But if you sit down and you're like, okay, this one will take me a bit of time, it's good to first just be honest and be like, I'll try, but I might not do it in the time that you expect me to be. I don't know, because I don't think there's a cut way to know, okay, this is me being lazy, or this is me pushing myself, or this is me being unrealistic, right? I don't know. I think it's just be true to yourself, because if you lie to yourself, then there is no amount of advice that will help you, right?
That's true.
Yeah. The first point is this is Eva. I say that I know C++, but in true, I've just done one or two things with it, right?
For me, this is another hack that I use, but I think I've liked the points you've raised, so I can try to put them down here. I hope you guys on the live, you can be able to see the notes I'm trying to write. If you can just put a thumbs up or a message. But so I've liked that step at a time, allow yourself to grow, maybe let's say if you're starting off as an intern, junior end, then grow step at a time, and then that's realistic, being realistic and being true to yourself. On the other one, there's this one that now this one is I think the general one, but the other part where actually they're really good, but they can't just trust they belong. They just feel I feel. Because the idea usually, I think, how this thing comes about is you've seen what really greatness is. You've seen great engineers and you just feel no, I'm not even 10%. But yet people are telling you, oh, I say you're good. So you're wait, who is lying to who, right? So I've just not one thing I guess I came, and I think we've talked about this in the previous conversation. It's just every level, the more you know, the more you start knowing you don't know. The more you realize, oh, there's so much here, I don't know. But still, don't forget that you still know that more, right? So also take pride in the more that you already know. At least most times we forget about it. So it's more like the half empty glass versus the half full. Yeah. So you already know more, but now you're still feeling small because of the more that you still don't know. So for me, I think it's good. First take pride in whatever you know, but don't settle there. Don't know that there's still much to know. But for my trick about how I beat imposter syndrome is just knowing that everyone, whatever, even if I meet Guido Van Rossum, the writer of Python, I already know there's so much thing that he also doesn't know, right? No one has this wealth of information, or they're a god in anything. They could be knowing in that particular thing. Let's say Guido knows so much about Python because the one who wrote it. But even you'd be surprised that even for him, he will tell you that there's things we are seeing people do with Python that I never knew you could do such a thing actually in Python, and they don't wrote the language. But people come up with even ways of using it that you can never maybe even know. So I take pride in that solace, not pride, but I take solace in the fact that knowing that everyone is trying to figure out things, like everyone doesn't know everything. But now you've brought up a very good point where you're in a team, like you've done a sprint planning, people taking task, and then you 1 week down the line you're still on task 1, people have done up to task 10. And then you actually, this person was task 10, actually they're one level below you, right? And now start wondering, am I really a senior engineer now? So, and then now the imposter syndrome kicks in. So I think that's like what now I've been talked about, like just being realistic. It could be that what I've noticed, like, it's just about the maybe we've just joined the team, I'm trying to understand how the thing works. So should I expect that by tomorrow already up? Yeah, so I think for that I'll defer to Eva's point, like on realistic timelines. So guys, yes, I know you guys know that I'm a senior here, but this actually is just going to take me 2 weeks. It's funny, but that's how true it can get, like just people. And with that, I think, because I know, like, I know that the truth is, like, as long as you've been true to yourself, you've amassed this knowledge with you. Like, there's nothing that will ever, like, destabilize you.
A follow-up question. Like nowadays, like there's a lot of people who get a lot of, maybe, I don't know if it's depression or anxiety, because like they look at social media and influencers, and everyone is doing so well, and then they are kind of looking at their life like, maybe they feel like maybe they're doing something wrong. And I think one of the common advice I hear is like, maybe turn off social media, or don't compare yourself to others, just be content with your life or whatever.
Yeah.
So I'm curious, like now in this space of imposter syndrome, it seems like a lot of it stems from comparing ourselves to others. So I'm wondering, like, is that something good, bad? Is that something that what do you think? Like, is that something, or is it just inevitable part of life, or part of being in a team?
To be honest, most of my anxiety problems and imposter syndrome stems from, I think, internal. I beat myself down with the issues pretty much, but I think for the other side, like people comparing themselves, for me, I usually think like this, like, okay, there's some things that are outside my scope of control, right? Like, one, the speed that people take to learn, that's one. Their upbringing, how they do things is completely outside my scope of control, right? That's one thing. And that's one thing I can't change pretty much. The second thing is understanding that things take time, I think that's easier said than actually implemented, unless you can look back to how far you've come, or like you know someone, like if you know someone who, like, you were with them when you're hustling, and maybe, it's easier to look at other people than yourself, right? So if you know someone who you were with them when they were hustling and they made it all the way to where they are now or whatever, it's easier for you to see that, okay, this guy was actually doing lead code, or like reading lectures or whatever. The realization that things take time kind of make it easier, right? It kind of makes it easier for you to understand that, okay, I'm in this path and I need to do 1, 2, 3 so that I get there. For me, that's how I think about it. And like, I can't control them, I can't control them. I can only control me. And for me to get there is what I need to, you can't sleep and wake up and things are okay, right? That's how I think about it. For the other stuff, the internal, beating yourself down, and no, that one I'm still looking for an for an answer, like for
I think for beating yourself up, I think I can tell it's okay. Because I think you have a high view of yourself, like in terms of like, no, I think I can achieve way more than what I'm doing right now, which is good.
Yeah, but it can tend towards self-destructive.
Yes, that's so that's a good thing. But now how to manage, knowing that it's a good thing, I know how to manage it. Like I know I have a high view of myself. You always want the bar is really always up there, right? But the thing is, the good thing is that with the high bar, whenever you try to reach it, still you'll do amazing stuff, even if you don't like that thing of aiming at the sun and landing at the moon. At the end of the day, you've landed at the moon. But for you, landing at the moon, you feel like, guys are clapping for you, like, oh, you're the first person to land on the moon, but they don't know. I wanted to go the stars. But even people are praising you, but you feel like, no, I'm not still arrived. But now that self-destruction is why you're still crying for the fact that you never reached the stars.
Yeah.
Right? Just crying like, well, guys, you already reached the moon. What's wrong with you? So, yeah.
You can't see that you're on the moon.
Oh, yeah.
You think you're...
No, actually you can see you on the moon, but in your head, you already... That's not where you wanted to be. You wanted to be on the stars, and your head is... in your mind, it was either the stars or nothing. Either land on the stars or nothing. So I think just chilling and... they say, you said taking a chill pill. So take a chill pill and just maybe taking that thing was step at a time. I think you already said those things, step at a time, which I think some people call it growth mindset, like just knowing that you're still growing. I think with that you can beat the imposter syndrome. With that, like just knowing that you're still growing and everyone is growing. Like no one should now, imposter can come into it. Someone can come now try to intimidate you. So where people want to intimidate you, that's what I use. Like, you know that there's still so many things you don't know. Or actually no one should never intimidate you because they know stuff. Because knowledge is just knowledge, right? Everyone can acquire it. So if you boast in like because you know something more than another person, that person can know it tomorrow, and then so that your boast now will be over. So I think once you know that, and then everyone is having a unique path. Everyone, even as much as even you might be in the same company, same team, but everyone is crafting like their own unique path and their own story, and you don't have to be duplicate stories. So if all our story was same, like it would just be boring. So I think, but it's something that you need to fight every day, I guess. Yeah, but I think it's a mental thing, because mental side you have to fight it mentally. It's not. Imposter is all mental. It's all in someone's head. So even you might meet someone and you feel like, hey, I respect this person, Mazai is one of my idols. Then I tell you, hey, Mazai, I don't know what I'm doing in life. You're like, what is it? You don't know what you're doing in life. I don't get it. Then if you don't know what you're doing in life, it's over. Even for me, I don't know where I can place myself. It's just mental. So, and so I want us to go to a few questions. Guys, you can ask questions on the chat as we close. I have some questions from our co-host who is not here, the chief architect. He had posted some questions there. Let me see if I can go to it. So, architect and poster. So this is Kubai, if you guys don't know. He has a channel. Go check it out. So I think we'll keep linking it in our notes. Kubai, we want to also support you. So he asked, how do you handle frustrations of not having the underlying knowledge necessary to learn a concept? E.g., having to require math knowledge to understand some computer science knowledge. And then I tried to learn, I think it was an extension. I tried to learn one thing and end up requiring to learn so much math to understand it. Yeah, I think it was a continuation. That's a legit question.
It's a very good question.
Yeah.
It's a very good question. I've had such experiences. One that I remember so vividly. Because I had like a personal crisis when I was taking a course in computer vision a couple of years ago. It was part of my master's program, and I never felt so out of place when I was in that class. I just started questioning myself because I was trying to learn follow along the class, and then they started like I thought I knew like the basics of linear algebra, but then it went so deep in linear algebra. I was like, wow, I felt so out of place and trying to catch up in such a short amount of time to be up to date with the course. It was so frustrating because you just feel like I don't know, I'm not getting this, and I think like maths, especially like this stuff like calculus or linear algebra, like they require a lot of practice. Like it's not just a matter of reading the concept. You actually need to do a lot of exercises until it becomes natural, until you get used to it. It's not a matter of just understanding a formula or something. So I don't really have a good answer. It's just, I try to learn enough like to pass either the assignment or the class that I'm trying to like went to some YouTube. I think there's this guy, this professor called Gilbert Strang. He has a very nice way of teaching linear algebra. He has, and there's like free lectures on YouTube, MIT Open Courseware, etc. So I try to just follow a few resources to learn like at least what was needed for those for those algorithms, at least to understand and be able to implement them. And then I told myself, okay, after this, I'll try to like go through like maybe there's some fundamental stuff, mathematics that are like fundamental in computer science. There's like discrete maths, there's linear algebra, maybe a bit of calculus and combinatorial stuff. So I just thought I could create a curriculum just to learn just the basics, not like maybe the CS11 version of those courses as a refresher. Just so that next time I see these things, even if I have forgotten, at least I'll have like enough fundamentals to go back and get a quick refresher. I don't know if that's a good strategy. It's time consuming because it's like now going back to school. And then not only is it time consuming, is that if you don't apply these things every day, you're also going to forget them as well. So even the next time, if the next time you apply these things is in 5 years, you might have to go through like a refresher again, stuff like that. So I don't know, it's frustrating. Maybe just be patient with yourself and just accept that this thing will take time. I don't know if there's a way around it.
I think that last was a good closer, like patience. Just patient with yourself. Because I think we put ourselves into a lot of pressure. Like even just in general, even in life, even I think there's something you mentioned about like you look at social media, compare yourself with the people, and then you just try, especially people, especially in 20s, late 20s, you just feel like you don't have time. But somehow you're just a third of like normal, like if everyone was to die at like 60 plus age, you're just a third way. Trying through, but you're feeling like you don't have time. You feel like, oh, I've not made it. Even the guys who get the 40 years midlife crisis kind of thing, you just start you're a young person. Life is just starting. But you just feel like you look at yourself, compare with your peers, people have gone, done stuff, and you just feel like you wasted your life. But I think just knowing that somehow life was just supposed to be the way it was, like for you. Like don't ever, because either way, even if it wasn't supposed to be that way, you can't go back and change it either way. So now that you're here, you just have to be like patient and do it. So I think I like that. Any questions on the live stream? If you have any other questions as we close down, I'll try and do a recap from my notes here and see if I have a full recap of things. I think I can be able to see questions from the phone here. Yeah, someone else, Gilbert Strang is awesome. I think we should share those. I think from this, you also sent me some links of some resources recommended from just our discussion, talk about the math thing. There's that book about like that tells you like, oh, read this and that and that. Plus any other book that you think about. You talked about like that being foolish or something. I really like that topic. What was that?
Importance of stupidity.
Importance of stupidity.
Scientific research.
There's also a book called None to Tetris. Elements of you read it? None to Tetris. Elements of computing systems.
No.
It actually also has a course on Coursera.
So tell us
Yeah,
that.
it's basically just something that tries to peel back the abstractions of a computing system from first principles. So it kind of starts with logic gates, and then from there you build like.
What? I like that.
But it's of course it's virtual, so it's not simplified.
Yeah.
But from the logic gates, you kind of build like the like a CPU, memory unit, etc. Then from that you build like with some instruction set, you build like an assembler from a minimized assembly programming language. Then you build like a VM, like a stack-based VM, and then you build like a VM translator that translates from the VM to assembly, and then you build like a high-level programming language that translates to that VM language, and then you build like a basic OS that supports that hardware architecture that you designed, and then you build now a high-level program, like usually a game. That's like the Tetris part of the name. That uses your language and runs on your OS on that virtual.
That's pretty cool.
What's the name of the? Let me just write it here.
NAND to Tetris. NAND as NAND gate.
NAND gate or NAND
to Tetris, or
to Tetris is
Tetris the game.
Is
TETRIS.
TETI
RIS.
It's a course.
It's a course on Coursera, but there's also a book called Elements of Computing Systems, and they kind of like teach the same material.
Elements of Computing Systems. Wow, that's awesome. Computing Systems, the book, right?
Yeah.
And then there's a course on check course on Coursera. This is my kind of stuff. But now the problem with these things, we should have also given a disclaimer that the biggest enemy of this thing is something called time.
It's very time consuming.
Yes. So
it's like that you're going to build Linux or something. It's a very simplified system, but like they give you like the general concepts. At least they demystify what happens when you run a program. At least
But then Warren, feel free to send us that link of Warren mentioned about the Go Strong. Also, there's a 3 blue, 1 brown playlist. We're gonna send us that playlist, and I'm sure Japheth Obal, I think you have some materials around building things ground up. If you have any of those things, you can send us on just this abstraction kind of thing. I would like to compile all this and put it in the description. By the way this thing is going, looks like I'll start off a mailing list and or sort of a newsletter that I send with this kind of information. So I'm actually thinking about that, like long form of it, like a blog or something. So you can do that. Before we do a party short closing, I would like to know the time hacks, because this thing needs time, as we mentioned. To understand these things, you need like time. You have your day job. You have even your bags that are really bugging you. Like, so do you? How do you guys actually handle like time to go into learning any of the basics of the things you want? To hack, productivity hacking.
For me, it's hard stop on work. At 5 p.m. stop on work to like do my other stuff. That's one. Another thing is like could get times of deep focus. I don't know if this applies to everyone, but for me, I'm the type of person who, when I'm in that deep focus zone, I just go with it. But when I'm not. I can't focus. So I need to like feel the time that I'm in, that I can do work and just go with it, and that time I use it to do my stuff. The other one, I think you definitely have to sacrifice. There will be one thing that you have to sacrifice, or one or two things. So it's about trading off what is really important to you. I guess.
Trade-offs, yeah. Something must give.
Something must always give. Like either that, or you take a very long time, which.
And okay, what else?
For me, well, I think I categorize the things I learn in different categories, but they're not formal. Like it's not like something I've written down. So there are those things I learn as part of my job, like something I learn in order to fulfill the task I have at hand.
Yeah.
So that those are usually easier to fit into my work schedule because they're kind of part of work. And so maybe I could have, like, if I'm going to do this task, I could devote maybe a day to kind of go through this concept, maybe go, and I think also have like a learning day thing that is I think in our team every month there's like a day that you're supposed to use for learning, though not doesn't always get to do it. And then now there are things, and then there are those things that I can learn opportunistically, like maybe I wasn't planning on learning this, but I see, okay, there's a 10-minute recommended video that I can watch over lunch or supper, that I also do that. But then now there are those things that actually plan, like maybe I want to learn this, I want to go through this book, I want to do this side project to kind of apply what I've learned. Those ones, what I've done over the years is just reduce the amount that I commit to per year out of realism. So I just try to do few of those, like maybe one of those at a time. Like let's say I'm going to commit to learning this topic. Maybe this is the book I'm going to read. I'm going to go through this course, I'm going to build this project, and it might take me a year. Sometimes it might take me 2 years if it's like a very wide field. And I think the issue there is the discipline of not taking up other stuff. So that I can commit the free time I have to just maybe this particular book or this particular topic, and with the exercises that it has. Because the challenge that I've had that I've made it difficult is like I start this and then I start getting that itch. There's this thing I'm curious about, I want to go into this, or I start to feel like maybe the industry is going this way and I've not caught up with the industry. So now I want to start like learning these things so that I can be up to date with the industry, and then I end up like not doing much. Like I'm just spreading my learning across different things and haven't really finished anything. So I think just this discipline of saying this is the main thing or the only thing I'll focus on in the next 6 months of the next year.
I have a thing about that to add actually now I've learned that. So towards the end of last year, around September, I started adopting this thing that kind of has really put my stuff in order. It's like the whole OKR planning. This like just personal, not external. So like now we're going to a new quarter, right? So I take the last quarter of this one that is ending to like go back to the stuff that I had put in backlog and do some research around like resources and things like that. And then I put on my main objectives for this quarter. I say, okay, at work, I have this key result that I want to do by the end of 3 months. At learning, I want to maybe, focus on security this time, or maybe learn a new language, right? I put it there, and you can even add stuff around life, right? Maybe something about health or whatever. Then you break down that objective to key results that are measurable. I say, for example, I need to finish 50 boxes in 3 months, right? Or I need to, things like that. And then I transfer this KRs, and every single week of the quarter, I break down this, from each KR, I put tasks for myself. So like I say, this week in security, I do 1-2 box, I do reversing, I do whatever. And then now, after that, you see now I have a palette, right? So I say Monday, I just take one task from this pool of the week and just put it in every day. So Monday I do this. So in a way, it kind of makes me organized, right? I know that, okay, this is what I want to do this week, and this is what I try to achieve. And then also, it kind of gives you a focus, right? You're like, okay, this time I took the last week or whatever based on the articles I've been reading last quarter, and I figured out, okay, maybe let me try to understand how the Ethereum virtual machine is like, right? And I'm like, okay, that's it, right? If anything comes along, if it's a small thing, right? Like if I have to do a CTF here, that's when you push it to the weekend, right? Any other thing, you put it on the backlog, and it kind of organizes you, because there's a very bad thing where you find yourself interested in, let's say AI, right? Machine learning. I don't know the right word. I'm not a person. Anyway, you get interested in, let's say, machine learning, right? You're like, okay, cool. I start a Coursera with Andrew NG, right? I get a bit bored. I'm like, all right, maybe let me learn about guns, right? There's this other cool. In 2 years, you're still exploring, right? Because you didn't really give yourself a good path. Or like, if I do this 3 months, this, I will,
I never thought about this. Like, and this one I'm gonna apply to myself. Like, it's true. You have, so even as you're speaking, I'm just writing a note, like, that planning aspect is really key. And then most of us, you have, they always say the road to hell is paved with good intentions. Because all of us have very good intentions of like, I want to know the basics of how everything works, right? And that's where we stop. Even you can go ahead, get the books. Even the books, we're gonna send you guys the links. You got the links, even you bookmark them, you put them like, I know I want to learn this thing, I'll learn them. But then we stop there. But now in execution, it's like, how do you now execute? So I think that planning is good, and then it also goes ahead like planning your time, the weekends, the holiday, everything. I think it's really key. I think I'm trying, because for me, I have so many. So for me, myself, just to be honest, I'm always with my life. I'm always having two things competing for my time, and now the third, and now family, like out of the family. One is music. I'm into music like very much. I want like once I retire from this kind of thing, I'll go into production, music production for real. And then computer science, right? So you are now you're torn, like what exactly, like in the morning, for example, every Saturday morning I'm always having something to do with music, like I do something with music, right? But then now computer science, what time can I get and all that? So it just calls for like organization. Because actually, I think even if anyone forgets anything, that's the key actually. Because we can talk about it, all this thing can look beautiful. You can actually even resonate with what we are saying, but for you to put this thing to practice, it needs the planning.
I also have a similar system, but mine is less strict. Like I have like an annual plan, so that just lists the thing out to achieve this year across like job, learning, personal, music, as you say, stuff like that. And then now each week, I say, okay, every Monday, I have like, what am I going to do this week? And then I just put them on like a sticky notes on like a whiteboard. And then those are the things I try to do this week. I try to have at least more stuff than I can accomplish that week. That way, if I finish the main stuff, I won't be like, okay, now what next? So most of the time, I actually don't finish everything, but at least I try to make sure that over the course of the year, I gravitate towards the main things on the like annual plan. So the annual plan, they're like things which are like, if there's one thing I want to accomplish this year, at least if I get to accomplish one, at least this is the top priority. So even if by the end of the year I finish the top priority, at least I won't feel that bad about myself. But then I have like the good to haves. So what I used to do in the past was have like very strict time box schedule, and I never managed, like it never worked out for me. Like I like things just happen, or things take more time than expected, or one day you are sick, or one day you have other things that you didn't plan for. So I that's why I went for this like very loosely designed model. Each week I just where I just have like I don't even say like in 3 months I want it, unless this thing can only, unless like there's a specific date, let's say I have to present something at a specific time of the month, then that's where I can unbox it. But usually I just have it open. And then like each week is when I try to say, well, where am I with this? I should focus on this, and then try to adjust accordingly. And but some things I can just drop off if I was too ambitious at the beginning of the year, and it's like half of the year, like okay, maybe this I won't even do.
But I think also, as you're speaking, I just remember that human beings, all of us, we are inherently like we have some laziness. That's true. Like all of us, like even the most hardworking person, you have some they're working on some things, but they're lazy on some other things. There are things that they always say, because I go to the gym. Or if you're into reading, you're always saying, I go to the gym. If you're into gym, you're saying, I'll read a book.
Yeah.
So I think putting like some pressure on you, because no school had a way of everything was time box. That's how it's like you do it or you don't. Like you not on your terms. You don't say, okay, I'll come and do this cut next week. I'll do this exam. I'll attend this lesson next. No.
Yeah.
Like you go for that. You are already time box, and that made us to really follow and do right. But now once you're out of school, self-learning. Now everything is now free.
Yeah.
So I think one thing that you mentioned that I think sometimes this has worked for me is, let's say if at work you have these things where you have presentation, offer yourself like guys, I'll present on this thing. I haven't even prepared, right? So it will, because you've already offered yourself, and you can't tell guys like, oh guys, even if you tell them, of course you'll move it by 1 week, but I don't know they're gonna learn it, and you're gonna like present. If you know yourself, if you know that you're kind of person who likes postponing sometimes, where like have like accountability in terms of you offer up to do something, and then now those people keep you accountable, and again at the end of the day you know the end goal is your own selfish goal. Like you present, yes, but you also gonna have to learn that thing.
Yeah.
So
I can try that and see if it helps me more.
Yeah, like you just say, like for example for you, I remember one time you presented something about memory management and stuff. I'm sure you went to learn so much about that thing, right?
Yeah.
But if you just said that, I'll learn about memory management at some point, it's okay.
But I only tried that. But I also like to, there's another parameter I like to regulate, which is the total self-imposed pressure. So there's amount of pressure that is necessary, like that is imposed like by work or school, and then there's also an amount of pressure that you add onto yourself. Yeah. So I try to regulate that amount so that it's like at least my life is not miserable. Like always under pressure, always under deadline.
Yeah.
So sometimes like
taking a chill pill is good. Like as you said, take life easy. Because also that's another thing about life.
Sure.
Yes.
There's this episode by Live Overflow. You know him, yeah, there's this episode, I think I'll give you the link to, where he talks about like the security space and around the meritocratic nature of it, and like how the whole space is like. So he talks about how like some people emphasize on like you need to put the time, you need to sacrifice, like it's very, because there's a lot of things that are changing, you need to learn, right? And the question is usually like, all right, you're not living life, or but in the end he says he gives a shout out to the people who live in their mother's basement, who are always on their laptop. Anyway, the thing I learned from there is that if computers is the thing that you find fun, right? Or if everyone has something that is, if computers are the thing that you find fun, or if something, you will make the time for it, right? You will find time to do it. And in that sense, you will want to like discipline yourself to get to a certain point, right? To like because in that case you need to discipline yourself more to not distract yourself from work to do the thing. Because I'm not liking work that much. I like this other stuff, so work becomes your side thing. In that case it's very important to like discipline yourself, either through tasks that you have to accomplish, right? Of all this other stuff, right? Or through checking yourself in terms of like, okay, after work is when I start this stuff, right? But either way, that is very needed. It's very needed for you to like have this set of things that you want to do, so that it keeps you in check. Because at Friday you'll be like, oh, I didn't do this, and yeah, it kind of keeps you in check.
Well, how bad do you want it? And then if you really like, if you really wanted it, I think you'll have time for it. I think that's one. Yeah. But even I like also giving guys even for the people who feel like I'm not really into it, but it's really necessary for you to be effective at work. It means you just have to like do that extra discipline. Even begrudgingly, you just still need to. It means waking up at 4 a.m. to do stuff. Yeah, you don't want to wake up, but you have to do it.
If it's a necessity, either by choice or by no choice.
Yeah, by no choice.
I think there's no way around it, right? You have to make the time pretty much and learn, right? Because there's no way that you can go around it. Right? If something requires building, you can't just do theory and be like, okay, yeah, I'm good, right? Yeah, you have to.
So guys, you can't imagine we've done 2 hours. The plan was to be 1 hour, but let me do but this was really awesome. Just bring it home. Quick recap. Guys also joined late. We started off with Kemunto giving us a life story, like how she got into tech, a journey into tech, cybersec, how you can go back and listen to it. One of the CTF is captured the flag. Basically, these are competitions in the cybersec security circles where people like have flags and you need to hack around the system to find that flag. So she marked top and then also she runs there's a Telegram chat or channel that she has that she will share with us on where she shares a lot of information on cybersecurity. Then I think we talked about our main thing today was about just abstractions, unmasking abstractions. Her approach is using breaking systems as a way of understanding how they work. So it was a very interesting discussion. You can go in and listen much on it. Another thing I picked was that a rule of thumb was going at least 1 or 2 abstraction layers down. I think is good enough. But maybe your end goal should always be like go up to all the way, as you said, all the way up to the end of it. Then there was from that even there's I think there was a suggestion of a course, the NAND to Tetris, the Tyrus, and a book there. I think I'm trying to zoom in here. You can see it. We also talked about veered and talked about imposter syndrome, because everything here is always related to imposter syndrome. Also, we'll always like bringing that topic, sneaking that topic in. So, talked a little bit about it there. A few notes, as you can see there. A step at a time. Embracing the growth mindset. Don't be realistic with yourself. Don't put out of unrealistic pressure on yourself, because you say, because this guy is not me as a senior engineer, this thing I'll do it in 1 day, right? And then now pressure starts. Okay, good. And then time hacks. I think we've closed with time hacks. I'm sure by now those who join late you've heard about the time hacks. We talked about I stop on work. If your work is 5 to 9, 9 to 5, by 6 maybe you already stopped everything and you're working on these other things like learning. It's a good thing. Some companies which I want to really to encourage, if you're here and you run a company of yourself, at least set aside some time for learning. For people, like put maybe a Friday afternoon. Don't just wait until Wajakoya gives people the 4 days, because I'm giving people Friday afternoons. Friday afternoons for learning. Yeah. So, but if the work does not allow you to learn, try and use extra times that you have. Plan. I think this was even my biggest takeaway myself. I'm gonna try to do this. Like have a good plan. Use like OKRs. Don't just stop at the objectives and the intentions. Like I want to learn this, but have the tasks. Like what do you want to do for this week, next week. I think I really like that meticulous approach that Kemunto has. Yeah, that was it. I'll leave you guys to have any parting shots from you, then from the guest.
I talked a lot, more than I expected. I don't think I have anything else.
Anything?
Me neither.
So we can close at that point. So guys, thank you for joining in, and if you're watching this later on, thanks, and see you on the next one. Bye. Let's see, I look for some music to end the streams. That will say like it should be anyone like some nice music.